students, welcome back to the discussion of the chapter Electrochemistry. And in this module, we are going to discuss about various electrical units. So, here the electrical units we are going to consider, of which very first is coulomb. It is the unit of quantity of electricity, and it is actually defined as the quantity of electricity passing through an electric circuit when 1 ampere current flows for 1 second. Alright, and it was actually named after Charles Augustin de Coulomb. Alright, so mathematically, if I want to say, we can say that I is nothing but current which is expressed in amperes, T which is expressed in time, that is time in seconds. Therefore, we can say that Q is equal to I into T. Alright, and here Q is precisely what we call charge or quantity of electricity in coulombs. Alright, it is the smaller unit for the charge or electricity. Okay, so let us have a look at relatively bigger unit for the charge, that is Faraday. It is a bigger unit of the charge and it is named after Michael Faraday. Okay, and now if I want to define Faraday, we can say that it is nothing but amount of electric charge which is present on 1 mole of electrons, and it is denoted by F. So we can say that charge on 1 electron is nothing but 1.602 into 10 raised to minus 19 coulombs. So if I consider 1 mole of electrons, the total charge present will be 6.022 into 10 raised to 23 into 1.602 into 10 raised to minus 19, which comes out to be 96,473 coulombs, which can be approximately taken as 96,500 coulombs. Therefore, we can say that 1 Faraday is nothing but 96,500 coulombs. Okay, so that was another unit which we have seen. Okay, going ahead, ampere. Ampere, it is the SI unit of electric current. Alright, and it is named after André Marie Ampere, which is actually a French mathematician and physicist. Okay, so now if we want to define ampere, it is nothing but the strength of an electric current which is obtained when 1 coulomb of electricity is passed through a circuit for 1 second. Mathematically, if I say I is nothing but Q upon T, right? So where we know that Q is nothing but charge or quantity of electricity passed in coulombs, and T is nothing but time in seconds. And we know that I is current which is expressed in terms of amperes. Going ahead with another unit, volt. The volt is nothing but the derived unit for electrical potential or potential difference or electromotive force, and it is named after Alessandro Volta. Okay, the scientist Alessandro Volta. So now we want to define volt. We can say it is nothing but the potential difference between 2 points of an electric conductor which is required to send a current of 1 ampere. Okay, therefore we can say here mathematically V is nothing but I into R, and here we know that V is nothing but potential difference in volts and R is nothing but resistance of a conductor in ohms. Alright, and that was with respect to another unit, that is volt. Next is joule. It is named after James Prescott Joule, and it can be defined as the work done per second by an electric current of 1 ampere flowing through the resistance of 1 ohm, or it is also defined as the electrical work done or energy produced when 1 coulomb of electricity is passed through a potential difference of 1 volt. So here electric work is precisely Q into V, and this product is expressed in terms of joules. We know here that Q is nothing but electrical charge in coulombs and V is nothing but potential difference in volts. Let's have a look at another electrical unit, that is nothing but ohm, which was named after the German physicist George Simon Ohm. And now if we want to define Ohm here, we can say it is nothing but the resistance of an electrical conductor across which, when potential difference of 1 volt is applied, a current of 1 ampere is obtained. It is actually the ohm symbolized as ohm here, the SI unit, derived unit for the electrical resistance. Okay, so that was with respect to ohm. So I hope students you have got a clear idea with respect to all the electrical units which we are going to use for our subsequent discussion as well. Thank you all.